Hello everyone, welcome back to my channel Neet Dost. I hope all my dear viewers are fit and fine. My dear viewers, when you are watching this video, please subscribe the video and don't skip at middle because each and every point covered in this video is so important and it's just a lesson covered in 10 pages. So don't skip at anywhere, watch till end, enjoy the reading, enjoy the explanation of me and get prepared for the NEET exam. So before starting this video, kinetic theory of gases is today's topic. This chapter holds one question in final NEET exam and the applications may be asked from this lesson. Without any delay, let's start the video. Here, coming to the topic, kinetic theory of gases. The first point is, make a note of this because this theory point has asked many times in NEET exam. Real gas almost behave like ideal gases only at high temperature and low pressure. Here the main point is high temperature, high temperature and low pressure. These two terms are most important in this line because in the final NEET exam they will give the statement real gases behave like ideal gases at which conditions. Suppose option A high temperature, low pressure. Option B low temperature, low pressure. Option C high temperature, high pressure. Option D low temperature, high pressure. Like this they will change the terms. You should be perfect here. High temperature and low pressure. Coming to next, remember these two formulas. PV equals to 1 by 3 mn V RMS square. This is the RMS velocity. Here the N stands for number of molecules, but not number of moles, it's for number of molecules. Coming to next equation, just modified of this, P equals to 1 by 3 mn RMS velocity square. Here N is number of molecules by volume, that's number of molecules per unit volume. Please watch the question. The, the term they have mentioned before giving the value of n, just they have given number of molecules or number of molecules per unit volume. Based on that word, the formulas will be changed. So these two are the most important. Make a sense and be careful while reading the question and underline these 2 points if you find in question. Coming to next formula, that's total kinetic energy, 3 by 2 PV, or instead of PV by ideal gas equation we will write it as 3 by 2 nRT. Here N stands for number of moles. Another equation of this is 3 by 2 PV or 3 by 2 nKT. Just observe here 3 by 2 nRT, that's for n moles. Here 3 by 2 nKT, here it's for n molecules. See the difference. Because we know K or we know the relation between K and R. Coming to next, RMS velocity. RMS velocity, we all know the definition. It's not need, it's unnecessary to discuss all those in rapid revision. Just remember the formulas. That's important. RMS velocity equals to root over 3RT by M or root over 3PV by M or root over 3P by D. Here D refers for density. Its volume, its molecular weight. R is the universal gas constant, T is the temperature, M is the molecular weight. This is the most important line. There may be a fine this statement is also based on one question. They will confuse you with giving a problem, but this is important because they will give all the problems and they will give all the numerical. But it is a small logic that RMS velocity is independent of pressure. Please make a note of this also. Next, coming to most probable velocity. That's root over P by D, root over 2RT by M, root over 2KT by M. Or we know K is the Boltzmann constant, M is the molecular weight, T is the temperature, R is the universal gas constant, D is the density, P is the pressure. Most probable velocity is nothing but the velocity possessed by most number of molecules is most probable velocity. Coming to average velocity. Average velocity is described as the velocity of all the molecules is divided by number of molecules. That's average velocity. The formula is root over 8p by pi d. Remember, you should not get confused whether by using pi, or you should not forget using pi. 8p by pi d, 8rd by pi m, 8kt by pi m. Same terms. M is the molecular weight, K is the Boltzmann constant, T is the temperature, R is the universal gas constant, T is the temperature, M is the molecular weight, P is the pressure, D is the temperature. Sorry, D is the density. Coming to next formula, that's velocity of sound, root over gamma p by d. Make a note. This will be asked because they do not ask directly, but they ask it in to find ratio between RMS and velocity of sound. Here I have solved this for you. Make a note for this also. It's a direct to save our time in final exam. Velocity of sound. The ratio of velocity of sound to the RMS velocity is root over gamma is to root over 3. Please make a note of this. Coming to next important point, that if a gas on a planet escapes, then RMS velocity is directly proportional. It is directly sorry. RMS velocity is greater than or equal to escape velocity of planet. Just if it is just escape, then the RMS velocity becomes equals to escape velocity of planet. We all know escape velocity, the term used in gravitation chapter. RMS velocity we have discussed earlier. Root over 3RT by M is equals to root over TG MP by RP. Here G is the gravitational constant, MP is the mass of the planet, RP is the radius of the planet. Here R refers to universal gas constant, T is the temperature, M is the mass. Make a note. Here they just ask a question based on this, like suppose a gas X has escaped from the earth with a radius R and mass M, then find the molecular weight of the gas. Like that, they ask some questions based on this. Coming to next topic, that's degrees of freedom. An important theory also. The theory question may be asked directly by the degrees of freedom. Degrees of freedom is defined as number of possible ways getting energy is called degrees of freedom. Here we classified this as mostly three types: monatomic gas, diatomic gas, triatomic gas. For the monatomic gas, the degrees of freedom is 3. Mostly the 3 are contributed by translatory motions. For diatomic gas, translatory motions are 3 and rotatory motions are 2. Finally, these 2 contribute to the degrees of freedom is 5. For triatomic gas, the translatory motion are 3, rotatory motion are 3, and they contribute both to degrees of freedom as 6. Here there is an exception, make a note. For linear triatomic gas, the degrees of freedom is 5. The degrees of freedom for linear triatomic gas is 5. For monatomic gas, the degrees of freedom is 3. For diatomic gas, degrees of freedom is 5. For triatomic gas, it's 6. Simply to remember it, just use the Titka 3, 5, 6. Same in this order. This is for monatomic gas. This is for diatomic gas. This is for triatomic gas. 3, 5, 6. Coming to next topic, that's law of equipartition of energy. Energy associated with each degree of freedom of a molecule is 1 by 2 kT. Energy associated with each degree of freedom is 1 by 2 kT. Here the total kinetic energy is given as degrees of freedom multiplied to the 1 by 2 kT. Here it is 1 by 2 kT is for each degree. There will be, for finding kinetic energy, it is multiplied with number of degrees of freedom. It's for one molecule. If suppose it is for one mole, then it becomes F multiplied 1 by R2 multiplied by number of degrees of freedom. Here the what's the difference means the term K and the term R. K is K is used for one molecule, R is used for one mole. And if it is for n moles, then simply it becomes 1 by 2 nRT multiplied with number of degrees of freedom to find total kinetic energy. From these terms, finding the term CV, most applied, most useful, CV is equals to F multiplied with R by 2, means number of degrees of freedom multiplied with R by 2. And CPE, number of R is multiplied by F by 2 plus 1 term. We should remember this. Simply, if we get 1, we can find other by using the relation Cp minus Cv is equals to R. By using the relation Cp minus Cv is equals to R. And finding gamma, make a note this formula also. Gamma equals to F plus 2 by F. Simply gamma is which is equals to Cp by Cv. Cp by Cv. Next, coming to another point. In vibrational motion, make a note of this. This is an exception. In vibrational motion, each vibration is associated with 2 degrees of freedom. 2 degrees of freedom. That's one is contributed by kinetic energy and another is by potential energy. This is the statement used full. Simply they will give a different gas which is not specifically mentioned whether it is mono, di or tri. But they will ask to find total number of degrees of freedom if vibration energy is also included. Then this statement will be useful to find the solution. Coming to next topic, that's mean free path denoted by lambda. Simply lambda is the average of all path divided by n. Coming to the formulas of lambda, means mean free path, lambda equals to 1 by root 2 pi d square n kt by root 2 pi d square p m by root 2 pi d square rho. Here we all know. Please remember these three formulas. Based on different context and different numerical, the formula will be changed. Based on the terms they have given, the formula we should use. In the first one, pi d square is the distance diameter of molecules, n is the number of molecules per unit volume, k is the Boltzmann constant, t is the temperature, d square is the diameter of molecule, p is the pressure, m is the molecular mass of each molecule. C, mass of each molecule. Here d square is the diameter of molecule, rho is the density of molecule. Coming to next, here we are going to discuss about numericals on kinetic theory of gases. The first numerical is the ratio of partial pressures of gases, hydrogen and helium are 5:3. Then find the ratio of number of molecules and find the ratio of density of gases. For the first one, they have asked to find number of molecules, ratio of number of molecules. They have given a hint like partial pressure of gases are 5:3. Make a note, partial pressure of hydrogen by partial pressure of helium is 5:3. We know the formula P1 PV equals to nRT. Instead of n, here we are using molecular fraction nu. P1V equals to nu1 RT. Nu1 is the molecular fraction of hydrogen. P2V is equals to nu2 R2 RT. Nu2 is the partial pressure of, molecular fraction of helium. When to find the ratio of number of molecules, let's divide this two. Then we get P1 by P2 equals to nu1 by nu2. For nu1 and nu2 are the molecular fraction we know. Then Molecular fraction is number of molecules of each gas divided by Avogadro number. Then N1 by Na into Na by N2. Here Na are the Avogadro constants, both gets cancelled. Then we get N1 by N2. That's 5:3 they have given. The answer for this is 5:3. Then to find the ratio of density of gases, d1 by d2 equals to m1 by m2 into v by v. That's equals to nu1 m1 by nu2 m2. Nu1 is the molecular fraction. We got it as 5:3 in the previous solved one. 5:3 m1 by m2. M1 is the hydrogen, molecular mass is 2. M2 is the helium, it's 4. Then 10 by here 2. Then we get it cancelled by 2. Then we get 5 by 6. That's d1 by d2 is 5:6. Coming to next question. 20 grams of hydrogen gas is in a vessel of volume 2 meter cube. It has translational kinetic energy of 4 into 10 power 5 joules. Find pressure and temperature. We know the formula PV equals to 2 by 3 kV. KE, kinetic energy. While rearranging this means simply sending the V to this side, we get 2 KE by 3V. On substituting the values in this term, we get 2 by 3 into 1 by 2. They have given volume as 2 meter cube, so 2 into kinetic energy as 4 into 10 power 5 joules. Before substituting the numericals, see once the units they have given for the constants. Then we get pressure as 4 by 3 into 10 power 5 Pascal. By again to find we got pressure right now. Then to find temperature, we are using the formula PV equals to nRT. 4 by 3 into 10 power 5 into 2 is equals to, this is the pressure, this is the volume, 20 by 2. This is the number of moles. They have given weight as 20. 2 is the molecular weight into 8.314. Here we are using the R in terms of joules into multiplied by temperature. After solving these, we get temperature approximately 300 Kelvin. Coming to next question. Here in a certain container, 5 molecules each having velocity 1 meters per second, 2 molecules having 5 meters per second, 10 molecules having 2 meters per second are present. Find RMS velocity, most probable velocity, mean velocity or average velocity. Here we know RMS velocity is the sum of squares of velocities multiplied with number of molecules divided by number of molecules whole power 1 by 2. Here simply using that definition we are finding. Then we get it as root over 95 by 17. Most probable velocity is the velocity possessed by most number of molecules. Here they have given 5 molecules contain 1 meters per second velocity, 2 molecules having 5 meters per second, 10 molecules having 2 meters per second. Finally, 10 molecules having 2 meters per second is the most probable velocity. 10 molecules have 2. So average velocity is the average of all velocities divided by whole. Then we get it as 35 by 17. Next question. At 27 degrees Celsius and at a pressure of 1 into 10 power 5 Pascal, the RMS velocity is 200 meters per second. Find the RMS velocity at 127 degrees Celsius and at a pressure of 0.5 into 10 power 5 Pascals. Here we are using RMS velocity at first. RMS R1 is 200, R2 we need to find. We are using the relation 300 by 400. It's based on temperature. Here they have given R1 is the first thing, 21. This is the T1 and this is the T2. R1 by R2 equals root over T1 by T2. Then we are using 200 into 2 by 3. Simply get two zeros get cancelled here. Root over 4 becomes 2. Well, sending that to this side becomes 200 into 2 by root 3 is equals to R. Then RMS velocity R2 equals to 400 by root 3. Simply using the formula R1 by R2. R1 by R2 is equals to root over T1 by T2. Coming to the next question. The average transitional kinetic energy of oxygen with molecular weight 32 at 27 degrees Celsius is 0.05 electron volt. Find the average transitional kinetic energy of nitrogen with molecular weight 28 at 27 degrees Celsius. Same temperature, two different gases. They have given kinetic energy of one molecule, that's oxygen. We need to find transitional kinetic energy of nitrogen right now. We know the formula. Translational kinetic energy. Translational kinetic energy equals to 3 by 2 kT. Here, K is directly proportional to temperature. They have given the temperatures as same. There is no term that is 3 by 2 is a constant, K is a constant. Directly, K is directly proportional to T. If the temperature is same, then the same kinetic energy also will be. Simple logic, no need to use the formula many times. We see, we make a major mistake here. They have given temperature, we use the formula 3 by 2 PV or 3 by 2 nRT. They have given N2 and we get confused again. Where is the mass? We may feel it as question wrong, but this is the logic. At same temperature, average kinetic energy will be same for all. So friends, this is a most important question. We get confused here using the formula. 10 power 25 hydrogen molecules strike an area of 10 centimeters square of a ball per second at 45 degrees angle, moving with 1000 meters per second. Find the pressure exerted by it. They have given mass of molecule is 3.3 into 10 power minus 20 grams. Here they are saying that in 10 power 25 hydrogen molecules are striking an area of wall at an angle 45 degrees with 1000 meters per second velocity, 45 degrees. This is the figure. They are striking like this and they get rebounced. Here, to find the pressure while making here, they will make some pressure on the wall. They ask you to find that pressure. Here we know the formula. Pressure P equals to force by area. Here we are using force as change in momentum to the time. Momentum by time. Delta P by A into T. To find change in momentum, number of molecules multiplied by 2mv cos 45 degrees. There is no time. Just resolve this into two parts. Y-axis gets cancelled and x-axis becomes 2mv cos 45 degrees A and T. Here number of molecules is 10 power 25. To mass of molecule they have given 3.3 into 10 power minus 20 grams. And cos 45 is we know 1 by 2 into 10 cube. The velocity. And A is the 10 centimeters square. And T is the time. But we take it for 1 second. Then finally, after solving this, we get the answer. Coming to next question, the diameter of nitrogen molecule is 2 angstrom. Its RMS velocity at 17 degrees Celsius under normal pressure is 5 into 10 power 12 meters per second. Find the average time interval between successive collisions. Lambda, simply using the formula, lambda equals to R kt by root 2 pi d square. Substituting the values, first we will get lambda. We will get the value of lambda. Let us assume the x. Then we are using the formula T because they have asked the time interval between successive collisions. Lambda by V RMS velocity. Simply like distance by velocity gives temperature. After solving this, we get the value of temperature. Coming to next. This question is most important in final exam. Has been asked many times in previous year. N molecules each of mass m of gas A and 2n molecules each of mass 2m of gas B are in same vessel at temperature T. The mean square velocity of B is v square. The mean square of x component of A is omega square. Find omega square by v square. Simply making the note difference between both A and B. Here it's n molecules, here 2n molecules, here mass is m, here is 2m, and same temperature. Here using the RMS velocity formula, root over 3 kt by m whole square, because it's for molecules. Here square we are using for 3 kt by m whole square. Here also root over 3 kt by m root over 3 kt by 2m whole square. Here we are making it as v square. Sorry, typing mistake. Here square is not there. Just 3 kt by m. Here also 3 kt by 2m. Typing mistake. Here v square is equals to 3 kt by m. Here root over 3 kt by 2m is equals to v square. Here directly v square equals to 3 kt by 2m. But they have given here components of this in this. They have not given any component in gas B. So directly v square equals to 3 kt by 2m. But they have given component here. Vx square plus vy square plus vz square equals to 3 kt by m. They have given its w omega square. So let us assume this all are equal. Then 3 vx square is equals to 3 kt by m. That's omega square equals to kt by m. Omega square by v square. Here finally we get omega square equals to kt by m. Omega square by v square. Kt by m into 2m by 3 kt. Kt gets cancelled and here m gets cancelled and finally 2 is to 3 remains. Then omega square is to v square is equals to 2 is to 3. Make a note. This is a most important question. To another important question. 4 moles of oxygen and 2 moles of argon are in a vessel at an absolute temperature T, neglecting all vibration modes. If vibration mode is also increased, again 2 degrees of freedom will be included. That's the theory point we have discussed earlier. Then they ask you to find total internal energy of system and find the energy required to dissociate 2 moles of oxygen at that temperature. Finding the first question, 4 moles of oxygen and 2 moles of argon we know. Then finding the total internal energy possessed by diatomic molecules and internal energy possessed by monatomic molecules. Simply using the formula F by 2 and RT and F by 2 and RT for di and mono separate. We know the degrees of freedom for diatomic gas is 5 using the Thitka 356. 356 is the Thitka we are going to use. 5 by 2 into 4 number of moles into RT. 3 by 2 into 2 and RT. Substituting this, we will get the final answer. U equals to 13 RT for the first question. For the second, here lies the most difficulty and we should need to use the logic. Simply, they have given energy to dissociate 2 moles of oxygen. 2 moles of oxygen and at that temperature. Means, if we dissociate 2 moles of oxygen, then 4 moles of oxygen in another case and 2 moles of argon will be remain same. Then, using for diatomic and mono separate, di is oxygen. It's sorry, yes, this is for di and this is for mono. I have written it reverse. Sorry, 5 by 2 is for di and 5 by 2 into 2 into RT. 3 by 2 into 6 into RT. No, it's perfect because here only this 4 moles of oxygen becomes into mono atoms after dissociation. Only 2 will be remain as di. So 5 by 2 into 2 into RT, 3 by 2 into 6 into RT. After getting cancelled of this 2 and this will be get cancelled by 3. Finally we get 5 plus 9 RT. 5 RT plus 9 RT. That's 14 RT. This is the final. Thanks for watching my YouTube channel, friends. This is the video based on kinetic theory of gases for rapid revision. Meet you in the next video with another important topic that's for rapid revision. Till then, stay safe, stay tuned, and get prepared for NEET exam. And wish you all the best at every moment. Don't waste time. And if you like this video, please provide us like. And if you have any doubts and queries, please post them in the comment box. I will reply you as early as possible. Thank you and bye bye.